Hi everyone. I'm excited to announce that we are starting the Autoware Podcast, where we will host expert guests to talk about a wide range of topics related to autonomous driving. Initially, we will delve into software defined vehicles and simulation topics because we will have exciting demos at the upcoming CES show. Our first guests are Casper Mecklenburg from Arm and Sophie and Oğuz Kağan Öztürk from Leo Drive. Enjoy the podcast.
Hi, Casper. Welcome to the first ever episode of the Autoware Podcast. I'm very excited to get this ball rolling as a part of our CS work now. And, we will talk a lot about software-defined vehicles during this series. And unsurprisingly, we will start by discussing the OpenAD kit. But before getting on the discussion, maybe let's get to know you first a little bit. Can you tell us about your roles at ARM and Sophie?
Yeah, absolutely. My name's Casper Mecklenburg. I work at ARM as an autonomous drive solution engineer. And in Sophie, I work with the software-defined vehicle alongside with a lot of other OEMs and tier ones and software providers. And what we aim to do there is find best practices and push them out into the automotive industry.
Uh, Casper, the software-defined vehicle is a macro trend in the automotive industry now, but there seems to be a lot of confusion around it. That's why I will ask the same question to the other guests in this podcast, but you will be the first.
Okay.
Can you tell me your understanding of the software-defined vehicle as an active participant in the work towards realizing that goal?
Yeah. So software-defined vehicles is definitely like a hot word or hot topic, kind of a buzzword today. And a lot of people have different interpretations of it. So how I think about the software-defined vehicle is that you have a set of existing best practices that can be borrowed from, for example, cloud native. Um, and then you also have certain technologies and also some new technologies. And you put all of these together. And the purpose of doing this is to make it easier to develop and deploy more advanced software in vehicles. And also, once you have it developed, it's easier to deploy across a broad variation of hardware as well, so that porting efforts are minimal.
So software portability is important there, and then also upgrading the software in the vehicle, and then hence upgrading the vehicle itself also is your understanding. Okay.
Yeah, absolutely. Because once you have this deployability foundation, then it's also a lot easier to upgrade the software in the vehicle, like you just said. So they go hand in hand, absolutely.
Okay, perfect. And you are a active member of the SOFI, and let's talk a little bit about SOFI and its underlying principles. Um Maybe we can start by what is SOFI and what kind of principles shaping SOFI's vision. Can you tell us about that a little bit?
Yeah, absolutely. So Sophie was founded, let's see, maybe 2, 3 years ago now, with the clear purpose of addressing the complexities in software development in the automotive industry. And it's open for anyone to join. And one of the main outputs from Sophie are the blueprints. And another important aspect is the Sophie software architecture. And the Sophie software architecture defines certain technologies or best practices that should exist in the software stack.
Okay. In the meantime, I just opened up a small slide deck I used to talk about the Open Educate in a Stuttgart symposium. Uh, this framework looks rather simple, but I know that this was a conscious choice. Can you talk a little bit about that? Like, what does the Sophie architecture tell us?
Yeah, no, for sure, and you're spot on there. It looks very simple, and the purpose of it is for it to be simple, because otherwise it's hard. The more complexity you have, the more difficult it is to achieve the goals of software defined. So if we start at the top here, we have the domain-specific application. This is any application that's running in a containerized environment. And then you have Sophie, which then provides the container runtime and a bunch of other technologies, which then sits on top of standards-based firmware. And the reason why it's important with like focusing on the standards here and the firmware is that it makes it easy for a Sophie reference implementation to move from one type of platform to another, but also different types of hardware. So you have edge, cloud, and virtual hardware as well. And the less you need to change between these different environments, the more you have to gain, because the less effort will be required when you need to move software around between different environments.
So what we're talking about is the hardware abstraction, right? We have a good middle layer, basically abstracting the hardware and the software, so software can be moved across different hardwares as long as the hardware manufacturer is building their hardware on a set of open standards and specifications.
Yeah, precisely. And this is what's so great about Sophie is that here is a forum where we can talk about these standards and agree and make decisions together and create alignment in the industry.
Okay, so which means probably on the application side, I know that Sophie is very big on the containerization of workloads, right? And the other part is, as you said, the application should be able to run at the edge, in the cloud, and also in virtual instances. So that means containerization and cloud native are very important to what Sophie is trying to accomplish here. But am I missing anything also important?
So like you say, once you abstract away the dependency on the hardware, you open up a lot of possibilities. For example, developing your application in the cloud. And there's also a lot of virtual technologies, which gives you the ability to create a so-called digital twin, which then gives you parity in the cloud, in the instruction set, in the operating system, etc., so that you with confidence can develop your application knowing that it's going to work at your final target hardware. So it really allows you to shift left in your software development and get your software at a very mature state a lot earlier on compared to how it's traditionally done.
So the software first instead of hardware first, right?
Yeah,
You're kind of trying to get that point. Yeah, perfect.
Yeah.
Casper, thanks for that again. Let me just shift gears a little bit and let's look at the OpenAD kits. So in this episode, we are talking about the OpenAD kit blueprint. That is the first Sophie blueprint, by the way. Mm-hmm. And we worked together at the OpenAD kit working group. This is in Autoware. That's a part of the Autoware project. Autoware comprises of different working groups. And the technical working groups are actually open to public, just like the Sophie working groups. And anybody can join. Of course, we are going to provide the necessary links and materials for people to navigate and understand how they can be a part of that journey as well. And we are working at the OpenAD Kit working group together to transform the Autoware software, because Autoware is, as we would expect from an autonomous driving software, is monolithic, but we need to make it a containerized workload, right? And that would make it software defined. So can you tell us what kind of activities happening at the OpenAD Kit working group? And what is the goal from your standpoint?
Yeah, I'm absolutely happy to share about OpenAD Kit. So OpenAD Kit runs weekly meetings, and in these, we never finish the agenda. We have a lot of things to talk about, and we also dive quite deep into technical details as well to create agreement, because we want to make changes that ensure that it makes Autoware better and software defined. So sometimes you need a lot of discussion there, which leads to very, very good decisions. So in the diagram we're showing here, you can see we're running Autoware in 3 different containers. So perception, planning, and control. And Autoware is based on ROS, which is based on DDS. And so this is how these different containers communicate. And then off to the side, we see we have maps and async over there, update client agent containers. And these are compatible with Autoware, but aren't necessarily part of the Autoware software stack. And what ties all of this together, we can see, is the SOFI reference implementation called eWall. And this comes with the hypervisor, but also just with a container runtime. It depends on what type of deployment you want. And so then we can run all of these containers on top of this operating system, and they can interact with each other, which makes the deployability very convenient. And then, so I'll use an example here that we're using the Ampere Ultra developer platform with an NVIDIA GPU, and they've adopted system-ready firmware, which is standards-based firmware, which makes it very easy to deploy any operating system, including eWall, on top of the Ampere Ultra developer platform. And then also we're working on deploying part of the software stack in a safety island, or as it says here, safety compute, which then if you stick to the standards and the communication protocols that we've agreed upon, also makes it possible for the high compute part and the safety compute part to communicate.
Which is super important, of course. There will be safety-related and non-safety related workloads, and using SOFI also different hypervisors helps us understand which are the non-safety and safety, so we can really assemble a heterogeneous compute platform which is necessary for the functional safety and further certifiability. Right? Yeah.
Yeah.
Okay.
So it's both a heterogeneous compute platform and also mixed criticality. So if you need to have like a high ASIL level, that type of compute can land in the safety compute. And if you need higher performance but not as strict requirements on safety or functional safety, then that can run in the high compute part of the compute platform.
Okay, thank you, Casper. Casper, you also touched there on the ROS2. Maybe not all of the viewers know it, but Autoware is based on ROS2. It's actually the entire stack is a collection of ROS2 nodes. So at the OpenADKit working group, we have in our meetings we have different segments, right? Usually we start with the Devops Dojo. Can you tell us about the Devops Dojo? And we are trying to modernize the nodes in a software defined way. But how are we doing that? Maybe tell our viewers some of our activities there.
Yeah, absolutely. So, because Autoware, the Autoware software stack already existed when we started OpenADKit. So we have a lot of legacy code and a lot of well-written code, great functions, and it was also complicated to deploy them in a flexible way. So how we've decided to take on this huge effort is to divide it up into smaller pieces or threads or processes, or like you said, we call them Devops Dojos. And this is a term which then focuses on a specific aspect of the software stack. So for example, in cloud native, configurability is very, very important. So in the context of SOFI, we talk to people and they introduce us to the 12-factor app, which outlines best practices in the cloud. And in one of those, it addressed configurability. So with that, we made changes to how to configure ROS nodes to make them more easily deployable. And another one that we're working on is breaking down the monolithic deployment of Autoware into containers. So it gives flexibility in deployment. For example, if you have a distributed system and you need 3 perception nodes, you have these containers which you easily can deploy to these edge devices. So there are a lot of benefits and flexibility in doing so. And we're working off of or checking one Devops Dojo off at a time, and eventually all these little puzzle pieces will make all of Autoware software defined and make it a lot easier for Autoware developers and users to deploy or develop and deploy Autoware.
Yeah, I totally agree. And as I said in the very beginning, unsurprisingly, we're starting with the OpenAD because it's one of the main drives now at the Autoware Foundation. And we are seeing more and more people coming into the OpenAD Kit working groups and really started to contribute. And one of those is actually there's a open call for volunteers, right? Because we have some 150 ROS nodes in the Autoware, and we are going one by one, and we are making necessary adjustments against the kind of like a predefined process. And people are pitching in and doing active contribution to transform those nodes. As I said before, we will provide the necessary links and materials when we alongside the podcast, so people also can explore it and participate in. Also, this is open source project, and everybody with the suitable skills are welcome, of course. And there is one maybe synergistic activity going on, right? Because Autoware is based on ROS, and ROS is a huge community on the robotics side, especially. And you made contact with the ROS community at IROS in Detroit very recently when we had an OpenAD kit demo on a chassis. Actually, it brought quite some popularity
Yeah,
to the
definitely did.
OpenAD kit as well. And what do you plan on doing with the ROS community there? We are giving something back, or we are pulling more people from the ROS community to help in our efforts. Tell us a little bit about that one.
Yeah, so conversations are very early on with the Rust community. But so in an OpenAD Kit call, I can't remember who, but someone said, "Hey, like this isn't really specific to Autoware or OpenAD Kit," and that was a very valid point because a lot of the changes we're proposing and making that address the deployability with the configuration files isn't specific to Autoware in any means. It's something that the entire ROS community would benefit from. And it's again bringing in best practices and making up creating some new ideas and merging these together to create a solution that works really well for ROS nodes. So yeah, conversations are very early on, but I'm sure a lot of the work that we're doing in OpenAD Kit, the entire ROS community would benefit from. So we would like to upstream and share this knowledge with the larger community.
Great. Thank you, Casper. I guess those are all the things that I had to get this started. I think that this laid out a very nice foundation. And in the next podcast episodes, we are going to be talking about other components as well, including the cloud native part, including the OTA part, including the workbenches in the cloud for the development tools and everything. So it's going to be a huge series, but this one has been very informative and laid the groundwork really. And thank you for joining the first ever Autoware podcast. I wanted to start this, but CES is always a good time to get this kind of activities started. And I was really glad to host you for the first one. And I hope you enjoyed it as well.
I sure did, Summit. Thanks for having me. I'm happy to talk to you again soon.
Perfect. Thank you, Casper. Talk to you soon.
Thanks.